Last problem is a little bit different than what we dealt with in the other 5. It was just a straight using magnetic force formula. Here's where we can bring in some stuff from Unit 2, where we can use some electricity formulas. Here we have an alpha particle accelerated from rest horizontally northward by a potential difference of 300 volts, enters a magnetic field of 5.6 times 10 to the negative 1 Tesla vertically upward. Determine the magnetic force acting on the particle. Well, let's start with what we know. We have an alpha particle, so we know its charge is twice the elementary charge. So 2 times 1.60 times 10 to the negative 19 coulombs. We know its mass, 6.65 times 10 to the negative 27 kilograms. We know it starts at initial velocity of 0 meters per second. We know it travels through a potential difference of 300 volts. And we know we have the magnetic field strength 5.6 times 10 to the negative 1 Tesla. We want magnetic force. When I get lots of information and I need more than one formula, I tend to write my information off to the side. So then I could take out my formula sheet and start searching for formulas. I'm going to start with my magnetic force of a charged particle, because that's what they're referring to. Magnetic force equals QVB. I have the charge. I have the magnetic field. What I don't have is the velocity. But I can get the velocity from conservation of energy when I'm dealing with an alpha particle being accelerated through plates. I also know that voltage equals change in energy over Q. So I can find the energy using QV, which I have. And I have a third formula that'll have me write energy, since this is going to be all kinetic, 1/2 mVF squared, since VI is 0. I can put all these formulas together to go find V using formulas 2 and 3. Then once I find V, go find magnetic force in formula 1. So what I'm going to write is, first of all, change in energy, which is going to be 1/2 mVF squared equal to QV. We worked with this formula in the last unit. We're going to manipulate this for velocity. So times by 2, divide by m. VF will be 2QV divided by mass. Take the square root. We have the charge. We have the potential difference it's been accelerated through. We have the mass of the alpha particle. Put the numbers in. 2 times 1.60 times 10 to the negative 19 coulombs times 300 volts divided by 6.65 times 10 to the negative 27 kilograms. Take the square root of that answer. Should give us a final velocity. And I could put this all into one formula, but it's kind of nasty. So I will do it separately. 2 times 1.6 to the exponent negative 19 times 300 divided by 6.65 to the exponent negative 27. Don't forget to take the square root, because I just about forgot to do that as well. And I get a velocity, and I'm going to round this, but I'll keep that actual number on my calculator for doing the force question. But this is 1.2 times 10 to the 1, 2, 3, 4, 5, 10 to the 5 meters per second. Put that into equation 1, so the magnetic force equals 2 times 1.60 times 10 to the negative 19 coulombs times the velocity. I'll keep the actual value on my calculator still. I'm going to have to write this over 2 lines, times 5.6 times 10 to the negative 1 Tesla. So it's 2 times 1.6 times 10 to the negative 19 times my velocity. I still have that on the calculator, so I'll multiply that by 2. I'll times by 1.6 to the exponent negative 19, and I'll also multiply by the magnetic field strength. 5.6 times 10 to the negative 1, and I should get 2.15 times 10 to the negative 14. I'm just going to check my velocity here. Yeah, I think that's right. Magnetic force 2.2, I guess, times 10 to the negative 14 newtons when we're looking at this magnetic force. Now all we have to do is work out the direction. So before I go and do that and walk away from this slide here, once you're given a potential difference, we can use that to figure out the magnetic field, or use that potential difference to figure out the velocity. Once we have the velocity, we can figure out the force. This is a very common type problem, and it's used quite often because it actually uses concepts from 3 different units. We worked on kinetic energy back in Unit 1. We worked on energy through an electric field and a potential difference in Unit 2, and magnetic force in Unit 3. So it's a really good unit to kind of review concepts from 3 different units. What we're going to do now is try to determine the direction. So we go back to the picture. It's an alpha particle, so we use our right hand. It's accelerated northward, so that means our thumb points to the north and the fingers come out of the page. So thumb to the north, fingers out of the page. That should tell us that the force in this question is to the east. So I'll write that force again. 2.2 times 10 to the negative 14 newtons to the east in this case.